Hello, Dave Hurst here with Athena Security. Today, I'd like to highlight some of the really great new features available in Athena FirePAC 6.0. The new change modeling capabilities allow you to design and test out changes to your firewalls before you actually deploy them out to the network. This lets you ensure that the correct changes are being made and to understand the impact of those changes.
With FirePAC, you already have the ability to review and explore your firewall configurations. Finding rules or objects of interest is easy with FirePAC search facilities. The traffic flow query allows you to identify risks and exposures to hosts protected by the firewall. And the rule object comparison capability lets you identify the differences in behavior between two versions of a configuration. FirePAC's change modeling takes all of the post-change analysis that was previously used for comparing two versions of a configuration and adds a powerful pre-production predictive analysis. The process to understand the impact of a change is completely straightforward, and it does not force a workflow process. Rather, it non-intrusively fits in along with your current day-to-day process. This, combined with the shared database backend, makes it easy for a group of engineers to make pre-validated changes to firewalls and removes the risk of disrupting any critical services or introducing any new exposures to the network. The reports that are created can also be saved and stored as a useful audit trail. There are some key differences that you will see in the new change modeling module. First is the ability to run the packet tracer to identify the precise devices and rules involved in a specified packet. These may originate from a change request or even an ad hoc change. Second, you can actually modify the rules in a safe container within FirePAC and run the rule object diff report to determine how the change is adding or deleting traffic. Third, once the change looks satisfactory, FirePAC automatically generates a script that can be deployed to the device, thus ensuring that the specified change has been applied correctly. Like all other FirePAC modules for network operations, this new module makes firewalls much easier to understand and less costly to manage. Let's take a look at how it works. When deciding to make a change in a complex network with multiple devices, the first thing you'll want to do is determine which devices actually need to be changed. I'll use a packet tracer query to do this. So here I'll enter the source, 206.82.204.150, destination, 10.48.7.15, and the service, and then run the query. The packet tracer takes FirePAC's ability to understand traffic flow in individual devices and extends it into the network. It performs an offline analysis that uses the firewall and router configurations to construct a network topology graph of the interconnections between devices. Then it finds all of the routable paths through the network from the source to the destination of the packet being traced and identifies the devices traversed by the packet along those paths. The result of this query is a packet tracer report. The report shows the packet being traced, followed by a summary of the paths found through the network. For each path, it will identify the specific devices along the path that will be traversed by the packet and whether the packet is allowed or denied by that device. I can drill into the details of the trace result to see the rule trail for each device. This shows the exact ACLs, NATs, and routes that affect the packet. Here I see that the packet is denied by the first device on the path, and it is a default deny in the netprod DMZ access in rule set. Now consider, had I tried to do this using traditional network analysis tools like ping or traceroute, I would have had to log into the source host and run ping or traceroute to find the first host blocking the path. Then I would need to review the configuration for that first blocking device, determine what change to make, deploy the change to the network, and then continue pinging or tracerouting to find the second blocking device, and so on in an iterative fashion. This process is time-consuming, potentially error-prone, and requires that I deploy changes to the network before I've even finished determining what changes need to be made. With the packet tracer, I can determine from a single query exactly which devices need to be touched and even which rules within those device configurations will need to be updated in order to implement my change. The next thing I'll want to do is to design the configuration updates that will fulfill my change request. I'll use a change modeling session to do this. The change modeling session provides you with the context in which to make changes to your firewall configurations. It's essentially a sandbox where you can design and try out configuration changes without affecting production deployments. To create a new change modeling session, I'll select the devices that were identified by the packet tracer from the firewall inventory, and then choose the New Modeling Session item from the Analyze Change menu. The Change Modeling Session view has a workspace that contains copies of the configurations for the selected firewalls, so you can make changes and explore the impact of those changes without affecting anything else. The various configuration comparison tools are available in the Change Modeling session, so you can see how the changes you are making will impact the firewalls being updated. To make a change to a configuration, I'll right-click on the file shown in the workspace and select the Edit Config File menu item. An external text editor is launched on the configuration file, which I can use to edit the configuration. I'll scroll down here till I find the netprod DMZ access in rule set, and then add a rule to allow the service that I'm interested in. When I close the editor, the changes I've made are saved back into the change modeling workspace. Now that I've made some changes, let's see what the impact of those changes are. Several tools are available in the change modeling session for comparing the modified configuration with the original configuration in the firewall inventory. These tools include Compare Text, Compare Rule Object, Compare Policy, and Compare Security Checks. The Compare Text tool shows a side-by-side text diff of the two versions of the config. On the left is the original configuration, and on the right is the modified configuration. Here, I notice a service group that's been modified. And scrolling down, I see the rule that I just added in the text editor. This shows syntactic differences. For a more semantic level description of the impact of my changes, I'll use the Rule Object Compare tool. This generates a report showing how configuration changes affect the behavior of the firewall. This report shows where changes to objects affected rules, even though the rules themselves did not change. In this example, we see a change to a port object, which originally contained 2 web services, and here a third has been added. On the Rule Compare page, we see a number of rules are listed that did not change, but are included because they refer to the object that changed. Of course, if a rule was modified, that will be indicated here as well, as we see here. But what we'd really like to know is how the behavior of the firewall will be modified as a result of these changes. The Impact Summary column shows us where a rule change caused changes to the actual behavior of the firewall. If we click on one of these entries, we are taken to the change in policy. Here we see a huge list of source addresses that are now allowed access to the SMTP service for this destination IP. If I was trying to make a change to enable access to SMTP from one host, this change was clearly way too broad and allows too many hosts to have access. We'll have to go back to the change modeling session and try something else. You also have access to the Compare Policy and Compare Security Checks tools. The Compare Policy tool shows you the impact on behavior and allows you to drill down to the individual rules responsible for the changes. In a sense, the rule object and policy comparisons are inverses of each other. The first is rule-centric and shows the changes in behavior stemming from individual rules. The other is policy-centric and shows the rules that caused specific changes in policy items. The security check comparison shows how the security posture of the firewall has changed. It evaluates the various security checks and shows if there were any changes from the original configuration. You can use this to ensure that any changes comply with your corporate security policies. Finally, once you're convinced that your changes are correct, you can use the Generate Change Scripts operation to generate a script that can be used to apply your changes to the device. This script contains the exact commands required to deploy your change. These change scripts function exactly as the other change scripts in FirePAC, such as for object standardization and rule object cleanup. They are well structured and highly documented, giving the engineer an opportunity to review the changes before they are pushed to the device. This allows you to deploy your change in a consistent and error-free manner.
As we have seen, the new change modeling feature in FirePAC allows you to design changes to your firewall configurations and to determine the impact of those changes before ever deploying updates to your production systems. A simple license upgrade will add these tools to your existing FirePAC installation, and as we have seen, the change modeling functionality will not disturb your existing change process. It merely makes the predictive analysis capability available to your engineers for a significant time savings.
For more information on obtaining the change modeling module in FirePAC, please contact sales@athenasecurity.net. And thanks for watching.